We're excited to announce that Consul 1.17 with Locality Aware Routing is now generally available. I'm here in the studio with Van, who works here at HashiCorp as a technical product marketing manager, who will be walking us through this new release. But first, for those of you in the audience who might be new to Consul, Consul offers a wide range of capabilities, including global service discovery in a multi-platform and multi-cloud environment. Using service discovery data, Consul can automatically update your networking devices like firewalls, load balancers, and security groups, enforcing zero trust security in your organization. Another valuable feature of Consul is that it has a service mesh that automatically secures all network traffic by authorizing, authenticating, and encrypting service-to-service communication. Consul also gives you the capability to shape and route network traffic, and we'll take this a step further with locality-aware routing, which Van is going to jump into.
That's right. Thanks, Jordan. So when we spoke to customers early on, many were racking up tens of thousands of dollars in monthly cross-zone and cross-regional traffic charges, and they were looking at ways to reduce the cloud cost through Consul. And the reason for these high costs was because many of these customers had multiple upstream service instances that were distributed across different availability zones, regions, or physical on-prem data centers for the sake of high availability. While this improves resiliency, this also increased cloud costs and application latency. So our solution to this is locality-aware routing in Consul 1.17. This feature automatically keeps traffic local and in the same availability zone between downstream and upstream service instances. And if local instances fail, traffic will automatically fail over to remote instances. So basically, Consul treats upstream services that are in non-local zones and regions as failover locations, which can help organizations save on their cloud bill and reduce latency. So to demonstrate this feature, here's an example diagram where Service A is sending requests to multiple instances of Service B, which is spread across different zones and regions, US East 1A, US East 1B, and US East 2A. If Service B instances fail in the local zone, US East 1A, Consul will reroute Service A to Service B instances in the adjacent zone, US East 1B. If those Service B instances in US East 1B also fail, then Consul will once again redirect traffic to the Service B instances in the next region, US East 2A.
Thanks for giving an overview on how developers can use Consul to improve performance, reduce costs, and also provide application resiliency with this one single feature. Is there a demo that we can check out?
Yeah, absolutely. So I have a demo here. Basically, I'm going to give a quick high-level overview. I do have a Kubernetes cluster. What I'm going to do is deploy two services in the same availability zone. So the services are a dashboard service, and that dashboard service will reach out to another service called a counting service. And basically, that counting service will increment a counter, starting from 0, and every couple seconds, it will increment. That dashboard service will reach out, grab that value, and reflect it in its front-end web interface. So then what I'll do afterwards is deploy multiple instances of counting in other regions and other zones. So you'll see here that I have two additional instances in US East 2B and US East 2C. And basically, dashboard is going to reach out to all three. And in our use case, we don't want that. We want that traffic to stay local in the US East 2A zone, right? Because of the fact that, again, we mentioned this, it increases latency and increases costs. So to enable locality-aware routing, what we'll do is set a config file, which we'll show in a second here with my demo. All right, so let's get into the demo itself. I do have a Kubernetes cluster already set up, and let's take a look at the nodes in that Kubernetes cluster. If I look at the nodes, you'll see that these three nodes in my Kubernetes cluster is distributed across three different zones, US East 2A, 2B, and 2C. Now let's take a look at my YAML file for my services, my dashboard service and my counting service. My dashboard service in the config file, I'm actually pinning it to US East 2A to ensure it stays in that one specific zone. Let's take a look at my counting service, and the same thing. I'm pinning it to the same exact zone to make sure both of those services are in the same zone. So now let's go ahead and deploy both of those services and see what happens. Okay, so now they're deployed. We'll go to that dashboard service and see what it reflects. And as you can see, it's reflecting the counting service, which is now incrementing from 1, 2, 3, and every couple seconds it'll increment, all right? So we know it's working, great. So now let's take a look at another file, another instance of my counting service. This time, this other file is showing that I'm pinning the counting service in US East 2B. All right, so it's going to be deployed in a different zone. So we're going to apply that and deploy it. So now if we go back to the dashboard service, it's going to reflect two different counting services with two different numbers because we started them at different times. And on the bottom, you'll see that's reflecting the different zones as well. Let's do it one more time just to show that example again. This time we're deploying into a third zone, US East 2C. And we're going to go ahead and deploy that and go back to the dashboard service. And as you expect, it's going to show three different values from the three different counting instances, right? And again, on the bottom, it's going to reflect the zones that it's reaching out to. So what we want to do is not have it connect to all three instances. We want to enable locality-aware routing. So we do that with this file called a proxy default, and it's a Kubernetes CRD. And basically within this file, there's a setting called prioritize by locality, and I set the mode to failover. So let's go ahead and apply this config file. And once it's applied, you can go back to the dashboard and see that it's only reflecting one single instance by one single stream of numbers, which means it's not trying to connect to some of those other instances in other zones unless a failover occurs. That's how we enable and configure locality-aware routing.
Thanks, Van. That was a great demo of Consul 1.17 with locality-aware routing. For all the developers out there that want to learn more about this new release, we actually have a link on your screen that you can visit where you can go to learn more. Thanks, Van, so much for being here.
Thanks for having me.